Hello, hello. Today we're working on data slash graphing. And the tricky thing about data is that probably fully a quarter of the questions on the math section on the SAT could be considered data questions, just simply meaning they have some kind of a table or a chart or picture involved. But those some of those data questions I'm covering in other videos like probability or statistics or the like. So I'm picking out random questions that don't maybe obviously fit in any category. So we're going to start with, hey, I did something wrong here. We're going to start with test 1, section 4, number 1. And we see there's a graph there. And it reads, John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? So if I was to draw a representation of something strictly increasing, I would go like that, and then strictly decreasing, I would go like that. Okay, so that's what we're looking for, this kind of structure. But now we have to look at the answers and look at the time frame. So A says between 0 and 30 minutes. And what I would do is, you can see that the x-axis is time. And we have 0 here, and then we have 10, 20, 30 here. What I would do is I would do something like this, like either color it in or circle these two. I kind of like the coloring in part, just make it really dark and then go up. And you can see that from 0, it starts to go like that. And then to 30, it just evens out, that means it's not decreasing. So A is not going to work. A is out. Now B says between 40, right? We have 40 here, and let's just put 60 here. 40, it starts, let's say here, I think it goes like that. So it starts here, and then it goes up at 50, and then at 60, from 50 to 60, it comes down. And this is this time frame that we're wanting. And we can see it goes up, then down, which is exactly what we drew, and B is going to be the answer. Once you find it, it's not really necessary to go over the others. Okay, so now let's skip over to question 15. Okay, it's the last multiple choice. Oh, no, it's not. Sorry. I was thinking of section 3. Okay, again, we have a graph, and I am going to just draw a simple representation of that. And our line starts up here at 5 and then goes up from there. And we have several points along the way, but I don't really care. We're going to do time along the x-axis and cost along the y-axis. And the question, going right to the question, because I don't really ever read a description of a picture, a graph, a chart, unless I have to answer the question. I always go right to the question. What does the c-intercept? And so C, we can see here at the top of the graph, it does say C. And this one says H. So the c-intercept or the y-intercept represent. Okay, now if we look at the top of the chart, we have a title. It says, total cost of renting a boat by the hour. And here we have the hours. But it's not starting at 0, right? It's not starting at the origin, right? It's not like this, which would mean that if you rent it for 0 hours, it's $0. That's not true. If you rent it at 0 hours, it's $5. And so in other words, it starts at $5 and goes up from there. So this $5 has nothing to do with actually renting the boat. There must be some kind of a flat fee involved, that no matter how often or how long you rent the boat for, you pay that $5. So let's look at the answers. And A says the initial cost of renting the boat, which that sounds just like what I'm saying, but let's look at the others. B says the total number of boats rented. That doesn't even make sense. the total number of hours the boat is rented is C. And that would make sense if we had this dotted line on this graph, right? If we started at 0, but we don't, we're starting at 5. And D is the increase in the cost to rent the boat. And it's not, okay? We have just simply $5 to start with. It's the initial cost. All righty. Moving on to number 22. We've got a big chart full of numbers. And I think let's do that. Okay, we've got a big table here. And 22 says, which of the following best approximates? So remember what I said on another video. When you see a word like approximates or is close to or something like that, about, you want to circle that word. So circle approximates. That means you know that when you get your answer, you're going to round it. Okay, we want the average rate of change in the annual budget. Okay, so I'm just going to write average rate of change. That's delta, means change. In the annual budget for agriculture natural resources in Kansas from 2008 to 2010. All right, so I'm just going to draw this chart out here. And we have the categories here, and we have ag is right up at the first, agricultural natural resources. That's the very first row. And then we have years. We have 07, we have 08, 09, and 10. Now, we don't care about 07, right? This question is asking from 2008 to 2010, and I would do what I'm doing, which is circle. All right, so now, actually, this would be more like down here, and then we'd have numbers. So we have our numbers. We've got, let's just cross that out there. We've got a number in here, and we've got a number in here. Okay, now I'm going to go back over to where I have more space. So let's see, we've got 2010 and 2008. We want the average rate of change. Well, how we find a change is we subtract. So 2010 is 488,106. 2008 is 358,708. And if we subtract, we're going to get 129,398. That's great. That would be the actual rate of change. But they're asking for, or this would be the actual amount of the change. The average rate of change means average. So we have two numbers. We're going to divide this by 2. It's the average over the 2 years from 2008 to 2010. And if we divide, let's see, I'm just grabbing my calculator here. Divide it by 2, we get 64699. Okay, now if you look at the answers, 65,000 is the closest. That best approximates this number. Okay, so your takeaway here is the average rate of change, and remembering average is the key word. All right, the last one is number 28 in this table anyway, in this test. All right, I'm going to clear the decks. So number 28, we've got some graphing here and quadrants. So we've got quadrant 1, 2. It's good to know the order of these quadrants, that it starts on the upper right and goes counterclockwise. All right, we have a system of inequalities. The first one is 2x plus 1. And the second one is 1/2 x minus 1. All right, there's a couple of ways you can do this. If you have a graphing calculator, you can put it into your calculator and see what you come up with. But even after you do that, you're just going to come up with a couple of lines. So we're not going to obviously do it on the graphing calculator, but we could graph these. Now there's a couple of ways to graph. You can, if you know what you're doing, you can see this as a similar to y equals mx plus b. We could say, let's say this is 1 and this is -1. All right, and then maybe do 1, 2, and 1, 2, 2, 2. Okay, so we have a y-intercept here of 1. That means it hits the y-axis at 1, and a slope of 2. And a slope of 2 means you can go up 2 and over 1, and up 2 and over 1. And if you want to go down, you can go down 2 and over 1. All right. So my drawing isn't perfect, so we're just going to not really worry that it didn't hit this line. And I think I should probably do this in another color. I'll do the second one in another color. Okay, now this one, this second inequality has a y-intercept of -1, and it has a slope of 1/2. So you can go up 1 and over 2, and up 1 and over 2. So it's going to look more like that, right? And that would probably intersect at some point like that. Now we're not done, because this is inequality, right? So, and this one says it's greater than or equal to. So we need to shade an area, okay? Greater than is going to be up above this blue line, okay? Up above it. And then the pink is also greater than. So it's going to be up above the pink line. Now, the question says, which quadrant contains no solutions? Now, no solutions means, well, a solution, let's say you have two lines, a solution would be where those two lines meet. In other words, this is a solution for the lines. When you have an area, it's where the areas meet or overlap. So we can see, I'm going to use a different color here. They overlap a little bit in 1, right in here, right? That's the overlap there. So 1 is good. They definitely overlap in 2. You can see that. It's like all this area. So 2 is good. 3, you can also see there's an overlap there. Now 4, the pink goes into the 4, but the blue never makes it. 4 is the answer that you're looking for. It's quadrant 4 or C. So it's not just where one of them hits, because if it was, there would be solutions in all quadrants. It's where they overlap. That's the key. Alrighty, that's it for test 1. Now let's go to test 2, and I think I'm going to erase all this. And we go to test 2, and let me get back to my black pen. Test 2, section 4, and we've got several of them. We've got 11, 14, 20, and 27. So let's start with 11. And 11, it's a little hairy. I have to say, it's a little hairy. We've got a lot of numbers and words. Okay, I'm not going to write down that table. Yeah, I'm going to try to avoid that. All right, we'll read. Tony is planning to read a novel. The table above shows information about the novel, Tony's reading speed, and the amount of time he plans to spend reading the novel each day. If Tony reads at the rates given in the table, which of the following is closest? So what do? You circle closest, because we know we're going to round. Closest to the number of days it would take Tony to read the novel. So we want closest to the number of days to read the novel. All right. They give us a lot of information. The trick is knowing where to start. Okay, so let's look at it. It says number of hours Tony plans to read the novel a day. Okay, that seems like it might be useful information, but I don't know if we can use it right now. Number of parts in the novel, number of chapters in the novel, number of words Tony reads a minute, number of pages in the novel, and number of words in the novel. Wow. Okay, we want days. Okay, so we're looking for days. So perhaps what we need to do is take, I think there's going to be conversion going on here because there's nothing in this table that says days other than the number of hours he reads per day, but that's hours, right? So this is going to be a multi-step question and we're going to have to convert, but let's not worry about converting yet. Let's just do the very first step. We have words, we have number of words, and then I'm looking for something else that says words, and then if I go up in the table, it says number of words per minute. Right, so this is number of words in the novel, total words, and then there's number of words per minute. So I like this because there are there's a kind of a common element in each. So we've got, I'm almost tempted to round it to make it easier. We could do that, but well, let's do it and see what happens. There's 350,000 words in the novel, and I'm rounding up clearly. And there are and Tony reads 250 words a minute. So what if we divided that? Now we're going to have it in terms of minutes, and we'll eventually change it into days. But let's see what happens. So 350,000 divided by 250 gives us 1,400. So what does that mean? That means he reads 1,400 what? Minutes? Words? Minutes. It takes him 1,400 minutes to read all of the words in the novel. Okay, does that make sense? This is in terms of words. It's all in terms of words, but it's minutes. It's how long it takes him to read the words in minutes. Okay, so it's 1,400 minutes, which we have to turn into days. Now, if we take minutes and, well, actually, I think I've covered this in an earlier video. This is converting. Depends on the order that you're watching your videos. But to convert minutes into days, we know that there's let's see. Let's do it step by step. Let's do hours. We have 1 hour. This is hours, and this is minutes. 60 minutes in an hour. And we have 1,400 minutes. Oh, whoops. Sorry, I knew that wasn't right. 1,400 minutes. So we cross multiply and we get 60x equals 1,400 and divide out the divide out the 60. Oh my goodness. And then we get 2, and I'm just going to do this on the calculator, and we get 23.33. Repeating. Okay, so that turns us into hours. Now we're going to do hours into days. However, we've got a caveat because normally there are 24 hours in a day, right? And it would be 1 day. However, he's only reading, what does it say? 3 hours per day. So every day is only 3 hours. So if we divide 23 or 24 divided by 3, you know what? Let's just change this to 24 since it's closest. That's 8. It's going to actually take him, instead of 1 day, because he's not reading for 24 hours. He's only reading for 3 hours. It's going to take him 8 days to read the novel. And B is our answer. Okay, it's a little hairy. It's okay if you decided to not do that problem, but it is a converting units problem, and it's also data. I put it under data, but either way, it's kind of both. All right, now we're going to go, I'm erasing this. We're going to go to number 14. Now, number 14, as you can see, has a graph and what we call a line of best fit. And it says, according to the line of best fit, that's that solid line running through all the dots, the best fit in the scatter plot above, which of the following best approximates, so around the word approximates, the year in which the number of miles traveled by air passengers in country X was estimated to be 550 billion. So if we just draw this out, this is the year. We have the x-axis is year, and y-axis is number of miles. And they're asking us for 550 billion miles. So we're looking for 550. And what they have on the y-axis is 500 and 600. Now, here's what's really important. There are a lot of lines and they're really close together. So what I highly recommend is if you find your 550 and you take your pencil and you just go all the way over, making sure you're not skipping over to a lower or a higher line. Now, we've got a line here. Let's just say it looks like that. And what you want to do, you have also dots on the line, right? Now, what people who get this wrong do is they kind of go dot, 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 and they kind of come down, so they hit a dot. And from there, they come down and read the year. But really, you should go straight across and hit the line and come down to that second green line. Also, the question says, according to the line of best fit. And the blue line is your line of best fit. It's not the dots around the line or even on the line. Okay, so this is, I'm going to just do it in a different color so it's clear. You want this light blue line right there. That's the one you want. And this is the year that you want. And the year should be 2003. The answer is C. This is an easy question, but it's incredibly easy to get wrong as well. Okay, so let's go to number 27. All right, 27 is a good question. It's a little intimidating, though, I have to say. It's a lot of words in there. So don't be afraid. All right, let's just draw this out somewhat. And honestly, I would not even read that paragraph. I would just go right to the question and only read the paragraph if necessary. So we have two lines. We've got, well, we have dots. They're not really lines. But we're going to create lines. So we've got this thing that goes something like this. It starts here, it's a steep slope, and seems to just get flatter as we go. Okay, and then I'll do the other one in another color. And this one starts at the same place and kind of seems to go down in a somewhat even pattern, and eventually, I'm not doing it exactly right, but okay. It's a little bit more like that. Maybe a little curvy. It's not perfect, but it's going to get you the right answer. So if we look at the answer choices, and we go right to them, It says in every 10-minute interval, the magnitude of the rate of change of temperature of the insulated sample, and we stop and we say, okay, which is insulated? We go up and there is a key, right? There's a box that tells us. We always look at that. The insulated one is the red one, the one on the top. Okay, so it says the rate of change of temperature of the insulated sample is greater than that of the non-insulated sample. And we can see that that's not true. The rate of change, this is much more gentle slope. This is really going down much faster. So A is out. Okay, B says in every 10-minute interval. You can see there, it's like repetitive, right? We're probably not going to have to read all these words. The magnitude of the rate of change of temperature of the non-insulated sample is greater than that of the insulated sample. Okay, so now is that true? Now they're reversing it. They're saying the non-insulated is greater for every 10-minute interval. We want to say yes, but I'm looking from, now let me change this color again. I'm looking from here to here, and I'm thinking like, well, that's kind of flat. And this is pretty slopey, like from here to here, right? So it's not for every single interval. So I'm going to cross that out. If you didn't catch that right away, you would leave that in and just analyze it later. C says, in the intervals from 0 to 10, right? So that's going to be from here to here, and from 10 to 20. So these first two sections. Blah, blah, blah. The rates of change are of greater magnitude of the insulated. So insulated is, remember, the red. So this is greater, greater rate of change. And then from 40 to 50, let's see, this would be 30, this would be 40, and this would be 50, and this would be 60 out here. Okay, the intervals from here to here, the rates of change of the non-insulated are greater. Well, we just said the non-insulated this is non-insulated and this is insulated. Okay, the non-insulated goes flat here. So that second half is not true. The answer has to be D. And if we've done our work carefully and really know that these are wrong, we don't even have to read D. Okay, so always look at the answers, and if there's repetition in words, then you can start to not read them, but you also don't want to skip over things that are really important. All right. Let's see, what else can I tell you about data? I mean, data questions really can look like anything. There is just a huge variety of what it can be. I guess one thing that I would say is I have seen, let's say there's a box and you might have like X and Y and different values for X and Y. All right, and then the question might say, which of the following answers shows the relationship between the numbers, the X and Y? And it might be like y equals 2x squared plus 1. Y equals 14 plus 3 to the x, right? It would just be various equations. And all you need to do is plug in the various answers. So let's say this is 0 and 5. Okay, I'm just completely making this up, so don't actually do the math. You would take 0 and 5, and you would plug these numbers in to every single answer, right? So 0, 5, 0, 5, 5, 5, 0, 0. And you would see which ones work. Now, truthfully, what they will do is maybe make A not work, B work, C not work, and D will work. So you have to make sure to plug in 0 and 5 to every single answer choice because they will make you do it twice. All right, so let's say the second one has 1 and 14. Then you need to do 1 and 14 and plug those numbers in, right? 1 and 14. You do the same thing that you did, 14, 14, 14, and 14, 1, 1, 1, and see which one will work. One of them will work, one of them won't, and you'll get your answer. Okay, so that, my friend, is data. Again, I can't possibly cover absolutely everything because it's just too enormous, but you'll get a lot of data questions running throughout the entire course. So have a great day. I'll see you next time. Bye-bye.